Hello everybody, you know how to solve a quadratic equation we have studied, and next we have studied how to study the behavior of quadratic functions with the help of the discriminants. Now we are going to study the quadratic inequalities. Consider this general inequality ax square bx plus c greater than 0. So we call it quadratic inequality. Either it can be greater than 0 or greater than or equal to 0 or less than 0 or less than or equal to 0. What we mean by solving these equations, these inequalities, we want to find the set of all x in R, such that these inequalities are satisfied. Then we say the solution of this inequality, for instance, if I consider this inequality, namely this ax square plus bx plus c greater than 0, if I am able to find a x in R, then we satisfying this inequality, we say that x is a solution of this inequality. Generally the solution x will not be unique, so we are going to find a solution set, that is set of all x in R, such that ax square plus bx plus c greater than 0. Okay. So this is what we mean by the solution set. Okay. And for instance, how to find this solution set, that is our aim in this lecture. Let me start with a simple problem. Let us solve this x square plus 3x minus 10 greater than 0. So what we mean by solve? We are interested in finding the x such that this inequality is satisfied. So we are interested in finding the solution set, and we can, this is a simple quadratic equation, the quadratic expression. This can be easily factorized like x plus 5, because x plus 5 and x minus 2, the product is the given quadratic expression x square plus 3x minus 10, and this is greater than 0. So the solution set is if and only if the solution set of this. Now we are interested in finding the set of all x satisfying this inequality. To make it easier, that is we want to simply, it is both the products should be positive, or both the products should be, both the terms should be negative, so that the product will be positive. So in order to understand that in an easier way, let me just use one notion called sine graph. It is a very very easy to understand this, otherwise generally students commit a mistake in finding the value of x. For example, I draw a number line. Let me put the 0 somewhere, and including this minus, because minus 5 is a root and 2 is a root. So 1, 2, 3 and so on, and here it is minus 1, minus 2, minus 3, minus 4, minus 5 and so on. Okay. Now what I do is, you take this first term, let us say x is equal to x plus 5, the first factor x plus 5 equal to that x plus 5 factor, and obviously the x plus 5 equal to 0 means x is equal to minus 5. At x is equal to minus 5, you put 0 here, and then on the right side of that you put all the plus signs, plus 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 for all the numbers here in between. I just written only the integers, so put the plus sign over that, because this factor is positive here, and here in the left side of the 0 you put the negative sign here, negative, negative and so on. This is what now we have done for the x plus 5. Now you take the next term x minus 2, then it is 0 when x is equal to 2. At x is equal to 0, x is equal to 2, you put the 0 here, and then right side of that you put the plus signs and so on. Similarly in the left side of that you put the negative sign, okay, and so on. Now you see the solution will be, we want this to be, so we want to be to get the positive, what we have to have is both should be positive or both should be negative. So therefore the solution will be somewhere, so here only we see all negative, both negative, here both positive. So in between you see from the 0 and the 2, it is having the plus sign and the minus sign. Therefore the solution is, the solution set is, the solution set from minus infinity to this minus 5 union 2 to infinity, okay, from the open interval, from open to infinity. So, minus 5, the points x is equal to minus 5 and x is equal to 2 should not be included here. So, that we have the strict inequality there. So, this is the solution set. So, the sign graph will be always very helpful in finding the solution set. So, that generally it is not necessary that you have to draw the sign graph, but just for the sake of understanding, so that you do not commit a mistake at the initial stage. Okay. So, next I move on to the one more similar problem. Consider this simple quadratic 2x square plus 5x minus 3 less than or equal to 0. Now, by factorizing this 2x minus 1 x plus 3, one can verify that this given inequality, the given expression 2x square plus 5x minus 3 is a product of these factors 2x minus 1 into x plus 3 less than or equal to 0. Therefore, the solution set of this inequality. So, what we are interested in finding the solution set. Okay, we have to solve this, and it is equivalent to solving this inequality. So, as I said earlier, use the sign graph. When x, so I draw the number line, and then x is equal to half, the first factor is 0 when x is equal to half. So, here it is 0, 1. So, let me say 1 by 2 is between the 0 and 1, and the 2, 3 and so on. Similarly, here minus 1, and again this is 0, the other factor is 0 when x is equal to minus 3, there minus 2, minus 3, minus 4 and so on. And now let us start with the first factor 2x minus 1. So, x is equal to half, it is, we put the 0 there on the top of that, and then you put the plus sign on the right side of that. And then similarly here the negative side, you put the minus negative signs. Now, the first factor is over. Now, we take the second factor x plus 3. When x is equal to minus 3, it is 0, therefore, put the 0 there on the top of minus 3, and then put the plus signs on the right side of that. Similarly, here that is negative. Okay. So, what we want is the product of these factors should be less than or equal to 0. That is possible if they have the opposite signs. So, that is possible only in this interval between the minus 3 and the plus half. Okay. Therefore, clearly we can write the solution. Therefore, the solution set is I have to include the minus 3 because less than or equal to 0. So, minus 3 is included, and similarly the half is included. So, this is the solution set for this inequality. Okay. Let me move on to the next problem. Here I am considering a different inequality, namely the a rational inequality. Solve. Okay. A rational inequality. A rational function means a function which is in the form of p of x by q of x. So, for instance, let me take a simple expression x plus 2 by x minus 3 less than or equal to 2. Fine. So, x plus 2, if I start with this x plus 2 less than or equal to 2 times x minus 3, if I cross multiply this, then what happens you see, then x plus, this implies if I bring everything to the one side, then it becomes the x minus 8 greater than or equal to 0. Obviously, when x is equal to 8, you see that it is when x is equal to 8, for instance, the numerator will be 10 and the denominator will be 5, it is less than or equal to 2, it is fine. Similarly, if you put x is equal to x is greater than or equal to 8, for instance, if I take x is equal to 9, then still the inequality is satisfied. Therefore, for all x greater than or equal to 8 will be a solution, but it is not a complete solution. Okay. For instance, if I put x is equal to minus 4, what is happening? If I put x is equal to minus 4, in this it is becoming minus 2 divided by minus 7, which is equal to For instance, if I put minus 4, minus 7, here it is minus 2, which is equal to 2 by 7. So 2 by 7 also is a, x is equal to minus 4 also is a solution, but that minus 4, x is equal to minus 4 solution is not given by this inequality. So what is the problem? The problem is with the cross multiplication. So we should not multiply like this. So the method is, if I go by this, then I will not get the complete solution. So what we have to do is, instead I take consider this given inequality x plus 2 divided by x minus 3, you take it to the left hand side, minus 2 less than or equal to 0, then you take the LCM. So the x plus 2 divided by x minus 3, x minus 3 minus 2 times x minus 3 less than or equal to 0, then this implies minus x plus 8 divided by x minus 3 less than or equal to 0, that is 8 x minus 8. I am multiplying both sides by the minus sign, therefore the inequality should be reversed. So x minus 8 divided by x minus 3 greater than or equal to 0. So remember, before you solve the inequalities, you should always see that the right hand side is 0. So you bring all the term to the one side, so that the one side of the inequality is 0, then it is, you won't commit any mistake. Now remember, to get this non-negative, this greater than or equal to 0, both the terms should be positive, or both the terms should be non-negative, or both the terms should be non-positive. Okay, so that is possible. Now again I can use the sign graph for convenience. Take the number line, and here remember x is equal to 3 and x is equal to 8. So here it is 3, here it is 7, 8 and so on. And then, so take the first term, that is x minus 8, the x minus, so at x is equal to 8 you put the 0 on the top, and then put the plus signs on the right side of that, and put the negative sign on the left side of that. And then now you take the x minus 3 factor and put at x is equal to 3, you put the 0 and then put the plus signs on the right side. Okay. And the left side of that put the negative sign. Now we want the signs should be same. Okay, that is possible only in the left side of 3 and the right side of 8. So therefore the solution set is from minus infinity to, I should not include the 3 because at x is equal to 3 it is vanishing. So it x is equal to 3, open bracket, union, then for all the x greater than or equal to 8, it is the inequality is satisfied. Therefore it should be closed bracket from a to infinity. So this is the complete solution. So generally if I do not follow that, if I cross multiply, I will be getting only this partial solution, I will not get this solution. Okay. So always make the one side of the inequality as 0, then you proceed as per I said. Now I move on to the one more simple problem. Take this 2 by x plus 4 greater than or equal to 1 by x plus 1. Of course these are all not quadratic inequalities, but we need to solve the quadratic inequalities. So as I said, do not cross multiply. What you do, you bring everything to the one side of that, so that you keep the other side 0. So 2 by x plus 4 minus 1 by x plus 1 greater than or equal to 0. Now by taking the LCM and simplifying, we get 2 times x plus 1 minus x plus 4 divided by x plus 4 into x plus 1 greater than or equal to 0, and this on simplifying we get x minus 2 in the numerator, and the denominator it is the factor x plus 1 and the x plus 4, and this should be greater than or equal to 0. So solving this inequality same as solving this inequality. Now as I said, now remember there are 3 terms here. Okay, so the thing is, we can have, if there are 2 positive and 1 negative, then totally we are getting the inequality will be affected. So therefore either all should be positive or 2 terms can be positive negative and one term can be negative. Okay. So now I can, it is always better to draw the sine graph for getting the answer in the easier way. So the numbers are -1, -4 and the 2, and let me put the 0 in the middle, and 1, 2, 3, 4, 5, -1, -2, -3, -4, yeah, -5. Now let us take the numerator, x is x minus 2 and x is equal to 2, you put the 0 and then put the plus signs on the right side of that, and negatives minus sign on the left side of that, fine. And now you take the x plus 1 term, x is equal to, at x is equal to -1, you put the 0 on the top of that and put the plus signs on the right side, and the left side, and the minus sign on the left side of that. Okay. Now consider the x plus 4. At x is equal to -4, you put the 0 and then right side of that put the plus signs and put the negatives on the left side of all the numbers. Okay. Now you just see the solution. So we need to have all positive sign. So remember, all should be positive, all should be positive, or 1 positive and 2 negative. Okay. Either all should be positive. So where is it occurring? All should be positive. For example, let us say here from 2 to infinity we have all are positive, and 1 positive is happening only in 1 positive, that is there is only 1 positive in this small interval, namely from -4 to this -1. Okay. So therefore the solution set is -4 should not be included because the new denominator will vanish. So -4 and similarly up to -1. -1 we have only 1 sign, only 1 positive. So -1 also should not be included, therefore the interval should be an open interval union, then from 2 to infinity. So we have all positive. So from 2 to infinity. So 2 can be included because it is in the numerator, and the inequality also it is a greater than or equal to inequality, therefore. So the complete solution set is the open interval -4 -1 union to infinity. So this is the complete solution of the given inequality. Now let us consider a quadratic inequality. Let us consider this term x square minus 2x minus 1 divided by x plus 1. This is less than x. So as I said, we should not cross multiply, we should immediately take the x term in the left side so that you make the right hand side 0. So the given inequality becomes x square minus 2x minus 1 minus x into x plus 1 divided by x plus 1 less than 0, which gives minus 3x minus 1 divided by x plus 1 less than 0. So therefore I multiply by negative sign on both sides, the inequality will be reversed. So 3x plus 1 divided by x plus 1 is greater than 0. So now the solution, now we are ready to write the solution. We can draw the again the sine graph. So at x is equal to minus 1, we put the 0 and put the plus sign on the right side of that, and on the left side you put the negative signs, and x is equal to minus 1 by 3. Here it is, here all plus signs, remember, here all plus signs. Now minus 1 by 3 is here, and then over on the top of the minus 1 by 3 you put the plus 0, and then on the right side of that put the plus signs, on the left side you put the negative signs. Fine. Now both should be positive or both should be negative. So that is possible only in either. So therefore either x is, both are negative, that is x is less than minus 1, strictly less than minus 1, because minus 1 should not be included, or x is greater than minus 1 by 3. Therefore now we can easily write down the solution. The solution set is minus infinity to minus 1 union minus 1 by 3 to infinity. Fine. So this is the complete solution of the given inequality. Now I just give a small exercise, you can try on your own. Simple inequality, x square greater than 4. Okay. So the solution, what should be the solution set? You can verify. Minus infinity to minus 2 union to t infinity. So this is the solution set. And now let us let me go to another quadratic inequality. Solve. So this is the solution set of this given inequality. Now solve this quadratic inequality, x square minus 4x minus 6 greater than 0. This cannot be factored. So far we have seen we have to factorize the given quadratic expression and then we were writing the solution set, but now this cannot be factored, but we know we can, but we can solve. This is a simple quadratic equation I can solve by using the quadratic formula. Solution root for the quadratic equation, we can write the solution as x is equal to 2 plus minus square root of 10. So the solution, the left side, that is at x square minus 4x minus 6 is equal to 0. So I draw the number line. So here it is 0, here it is minus 1, here it is minus 2. So it the first root is lying between that is 2 minus root 10, 2 minus root 10, which is equal to minus 1.2, is lying between the minus 1 and 1. And here it is 1, 2, 3 and so on, and 2 plus root 10 is after it is a number greater than 5 but less than 6. So therefore this second root is here 2 plus root 10, which will be somewhere around 5 approximately. It is approximately, not equal. Okay. So this is equal, it is not equal. So 5.2. So at 5.2 I put the 0 up here, and then the plus signs on the right side of that, and the left side I am putting the negative signs and so on. Similarly here I am putting the 0, and the right side I am putting the plus signs, and on the left side I am putting the negative signs. Now to make it positive, remember we have to have both should be positive or both should be negative. Okay. So here it is plus, plus and so on. Okay. So therefore the solution set will be, so here both both are positive on the right side of 2 plus root 10. Okay. So therefore 2 plus root 10 to infinity both are positive, and from minus infinity to 2 minus root 10 both are negative. So therefore in both the cases we have the strict inequality greater than 0. So therefore this will be the solution set. Now let us go to some inequality involving some other functions like modulus function. Okay. And before that I wanted to remember this, whenever mod x is greater than a, mod x is greater than a, okay, this is what it means is, if it is, this is very simple, this mod x is less than a is very simple, people do not get confused. This is if and only if I want to break the modulus, we can say that the x lies between minus a and the plus a, this is x. If I break the modulus, then we have to write like this, minus a less than x less than a. Whereas for mod x, so this let me write as an important note, when mod x is greater than a, generally people commit a mistake. When mod x is greater than a, it is if and only if, that is x is greater than a is fine, or x is less than minus a. So, if mod x is greater than a is some constant, this is if and only if x is either x is greater than a or x is less than minus a. Okay. Whereas in this case very simple, mod x less than a, it is if and only if minus a less than x less than the plus a. Similarly, we can write, already we have seen one given the exercise, in that also we have considered the involving squares. For example, x square is greater than a square, immediately if and only if is greater than a square. So, like it is exactly like this, either x is, so simply people write, generally people write x is greater than a, leave it, no, it is not correct. So, what we have to do is x square is greater than a square, it is if and only if either x is greater than a or x is less than minus a. Similarly, for x square greater less than a square, then it is same thing similar to this case, okay, if and only if, that is x is the minus a less than x less than the plus a. So, these are the important things, generally we come across this type of inequalities, then immediately we if I want to break the square or we have to break the modulus, we have to replace it with the this right hand side expressions. Okay. Now, let us consider one inequality. Let me take this simple inequality, modulus of x square minus x greater than 2. What is the solution set of, that is for what values of x we have this modulus of x square minus x greater than 2. So, already I told you to break the modulus, we have to say this is true by this property, I am just writing, that is either x square minus x is greater than 2 or x square minus x is less than minus 2. Now it is very simple. Now as like before, I bring it to the one side. So, x square minus x minus 2 greater than 0 or x square minus x plus 2 less than 0. Fine. So, now I can factorize this. So, this is if and only if this inequality is if and only if I can factorize this x minus 2 x plus 1 greater than 0 or x square minus x plus 2 less than 0. Okay. This is true by again by the sign graph, I am not repeating this. So, this is if and only if x is greater than 2. So, both terms should be positive or both terms should be negative. So, either x is greater than 2 or x is less than minus 1. Or now consider this inequality, here the discriminant b square minus 4ac is always negative, therefore, there is no x satisfying this inequality, okay, no x satisfying this above inequality, no x in R satisfying this inequality. Therefore, the solution set is from minus infinity to minus 1 open interval union 2 to infinity. So, this is the complete solution set of the given inequality. Next a similar type of quadratic inequality, but involving modulus signs. Consider this x square minus 2x minus 5 times x minus 1 plus 7 less than or equal to 0. So, now by looking at this inequality you can see that this is something, if I look at the first two terms x square minus 2x, this is exactly behaving like x minus 1 whole square except the constant term. So, therefore, simply I can write x minus 1 whole square. So, this I want to solve this inequality, this is the given problem. So, I am writing this x minus 1 whole square, then the inequality becomes 5 minus 5 times x minus 1 plus 6, because already 1 is here. So, less than or equal to 0. So, remember mod x minus 1, so this is simply, it is modulus of, I can write this x minus 1 whole square as x minus 1 whole square modulus of x minus 1 square minus 5 times x minus 1 plus 6 less than or equal to 0. Now, I can the easy substitution, so that it is converted into the real quadratic inequality. So, put y is equal to modulus of x minus 1. So, the given inequality becomes, now we have the quadratic inequality, y square minus 5y plus 6 less than or equal to 0. On factorizing this is a very simple quadratic expression. So, I can factorize this y minus 2 y minus 3 less than or equal to 0. Therefore, both should have the opposite signs. So, by using the sign graph, so I am not writing the sign graph here. So, therefore, the solution, this implies y, the solution set is y is belonging to, if and only if y is belonging to this 2 comma 3, okay, 2 comma 3, the interval 2 3. That means modulus of x minus 1, the y is nothing but modulus of x minus 1. What it means is that 2 modulus of y minus 1 is lying between 2 and 3, the 2 less than or equal to modulus of x minus 1 less than or equal to 3. Okay. Now, I am taking one side one side inequality, first inequality 2 less than or equal to mod x minus 1. This is if and only if. So, mod x minus 1 is greater than or equal to 2 means, we have already seen x minus 1, because mod x is greater than a means mod x greater than a, it is implying x is greater than or equal to a, or x is less than or equal to minus a. The same thing I am applying here. So, 2 less than or equal to modulus of x minus 1 is if and only if x minus 1 is greater than or equal to 2, or x minus 1 is less than or equal to minus 2. So, this gives this if and only if again x is greater than or equal to 3, or x is less than or equal to minus 1. Okay. Now, I take the other inequality, mod x minus 1 less than or equal to 3. Already we have seen, if mod x is less than or equal to a, if and only if it is lying between minus a and plus a, the x is lying between minus a and plus a, and hence we can, this is if and only if minus 3 less than or equal to x minus 1 less than or equal to 3, which is if and only if I keep the x in the middle. Therefore, it is minus 2 less than or equal to x less than or equal to 4. Therefore, the solution set, now I can write the solution set. It says, now we have to write the common domain. Either it says x is greater than or equal to 3 and x is less than or equal to minus 1. Here it says it is lying between minus 2 and 4. Therefore, the solution set will be from minus 2 to minus 1, certainly there, okay, because x is less than or equal to minus 1 and x is greater than or equal to minus 2, therefore this interval is there, union, and it says x is greater than or equal to 3 and here x is less than or equal to 4, therefore it is 3 4. Okay. So this is the complete solution set. So the only thing we should consider both the inequalities separately, this inequality and then again this inequality, and then we are writing the solution set, and then we are writing the common region which is satisfying both the inequalities, that will be the solution set for our the given inequality. Okay. Now let us see some problem with a different flavor. Now little abstract, I want to solve this. Solve ax square, a is a number, a is a constant, non-zero constant, ax square minus a plus 1 x, a plus 1 x plus 1 less than 0. I want to solve this where a is not equal to 0. So how to find the value of x so that this inequality is satisfied? It is given that a is a non-zero number, and right now we cannot factorize unless we know the a. So what we do is we simply solve, because we know how to find the roots of the quadratic equation. So this is equal to x is equal to a plus 1 plus minus square root of a plus 1 square b square minus 4ac minus 4a, okay, divided by 2a. So this gives my solutions as, by simplifying, it is a plus 1 plus minus a minus 1 divided by 2a, and it is giving my solutions as 1 and 1 by a. Okay. When a is equal to 1, what is happening? So a is non-zero number. When a is equal to 1, when a is equal to 1, the given inequality is nothing but x square minus 2x plus 1 less than 0, which is nothing but x minus 1 whole square less than 0. This will never happen. There is no value of x such that x minus 1 whole square is less than 0. So therefore when a is equal to 1, there is no solution at all. There is no solution. Okay. Now let us take the other case. It is given that a is just a real number, non-zero real number. A is a non-zero real number. Now when a is greater than 1, what is happening? When a is greater than 1, obviously 1 by a is less than 1. A is not equal to 0, remember. Therefore now I write this, let me use the sign graph for convenience. Let me put the 0 and 1 by a is the number less than 1, 2 and so on. Here it is minus 1 and so on. The top of 1 I am putting the 0, and the right side I am putting the plus signs, and here on the negative sign minus signs, and then again the same for 1 by a I am putting the 0 here and the positive on the right side and the negative minus sign on the left side. And to make this inequality less than 0, what we have to have is both should be, they should have the opposite signs. So therefore the solution, so that means 1 plus and 1 negative, that is happening only in between the, so here it is plus sign, remember. So on the right side of 0 it is plus, on the left side of here, when the left side of 0, here it is negative. So negative signs. So that is, so therefore the negative and positive, the both signs different is happening only between the 1 by a and 1. So therefore I can write the solution set when a is greater than 1. Solution set. So the solution set is not unique, it is depending on the constant a. So when the solution set is 1 by a and 1. This is the case when A is greater than 1. Now, let us see the other case when A is a number. A is a, let us take A is a positive number. Let me take this third case when A is lying between 0 and 1. Therefore, 1 by A is greater than 1. Therefore, in this case the solution will be obviously between the solution set. You can verify that the solution set from 1 to 1 by A, exactly similar to that, but it is in the other side, 1 to 1 by A, this open interval. Now, let us consider the A negative case. When A is negative, what is the inequality? The given inequality becomes now consider, let us see go back to the original inequality. Ax square minus A plus 1, when A is negative, this inequality becomes x minus 1 by A into x minus 1 less than 0, sorry, greater than 0. Then again by seeing the sign graph, I can write down the solution set. Remember, both terms should be positive or both terms should be negative. Therefore, we have two intervals. Solution set is minus infinity to 1 by A union 1 to infinity. Okay. So, the solution set is depending on the parameter A. So, that so we have to be careful in dealing with every possible case here. So, we have seen the cases when A is negative and A is positive, and when A is positive we have seen the cases A is between 0 and 1, and also when A is greater than 1. Now, let us look at the problem where it is something converse in nature. That is, I am giving the solution set and then accordingly I am finding the values of the parameters involved. For instance, let us say it is given that x square ax square minus ax minus 1 less than 0 for all x, that is this inequality for all x belonging to the real line. For all real numbers, ax square, A is an unknown parameter, ax square minus ax minus 1 less than 0 for all x belonging to the set of all real numbers. Now, we are interested in finding what will be the value of A. What would be the value of A? So far, we have given the equation and then we found the x satisfying the inequality. Now, we are saying that the inequality is satisfied for all x belonging to R some domain. So, here the domain is the entire real line from minus infinity to plus infinity, and then now we are interested in finding the value of A. The one immediate observation, when A is equal to 0, minus 1 less than 0 we get. Therefore, it is satisfied for all x, obviously it is satisfied, and hence when A equal to, therefore, the value of A is A equal to 0 is one solution. So, what is the value of A? That is a question. Obviously, when A is equal to 0, we get the left hand side becomes minus 1, which is obviously less than 0, and hence when it is automatically satisfied for all x belonging to R. Therefore, the inequality is satisfied when A is equal to 0. Therefore, inequality is satisfied. For all x in R. Therefore, A equal to 0 is one value, that is one solution of the given problem. Now, take the case A not equal to 0. Since this inequality is satisfied for all x belonging to R, the graph has to be the quadratic expression y equal to ax square minus ax minus 1 has to be only in this pattern, it is negative. So, in that case our discriminant d, which is equal to a square plus 4a should be negative, which implies, which is if and only if a into a plus 4 negative. So, obviously a cannot be positive here, because if a is positive, a plus 4 is positive, which cannot happen. Therefore, a is negative, that we are very sure, and hence the solution will be, so therefore a is negative, therefore I am a plus 4, a is negative, a plus 4 should be positive, which implies a is greater than minus 4, that, and a is negative. Okay. A cannot be positive, remember a cannot be positive because of this inequality. Therefore, a has to be negative and a should be greater than minus 4. Therefore, the solution, the a can be only on this interval. Therefore, a belongs to only this open interval minus 4 to 0. Okay. Already a equal to 0 is a solution, therefore, we can add. Therefore, the complete solution set is minus 4. It is not open interval, so I can include the 0 also, because a equal to 0 also is a solution. Therefore, this is the solution. So, let me take one more problem of this similar type, but the inequality is satisfied only for a small set, not the entire real line. Let us consider this example. It is given that, maybe let me write, if ax square plus bx plus c greater than 0 as a solution, as the solution set 1 less than x less than 2. Okay. So, therefore, this inequality is satisfied only on this open interval 1 2. Then what is the solution set of the other inequality, some related inequality, namely the cx square plus bx plus a. Now, how do we proceed? Now, let us take the given assumption ax square plus bx plus c greater than 0 for all x in the interval 1 comma 2. So, it is given ax square plus bx plus c greater than 0 for all x belonging to the open interval 1 2. It is given. This implies, remember, the function is positive, the graph of the function will be like this. What it means is, this is the 1 2, the x axis. Here it is positive on the interval 1 2, it is positive. So, therefore, and the rest of the interval it is the solution set is the complete solution set is 1 2 interval. Therefore, the solution has to be only in this pattern, this convex graph. Okay. Cannot be any other pattern. And obviously, for this is a concave graph, and this implies a has to be negative. If a is positive, the graph will be in the other, just opposite. If a is positive, the graph will be in the other way. Since it is positive, ax square plus bx plus c is positive on the side 1 2 interval, and the rest of the interval it is negative. This forces that a is less than 0. Therefore, I am just for all x belonging to the 1 2 interval, I am dividing by a, x square plus b by ax plus c by a will be negative, because I am dividing by the negative a. Therefore, the inequality is reversed, which is true. Now, this quadratic expression, this is if and only if obviously the solution set of this inequality is 1 2. This is same as saying that x minus 1 into x minus 2 is less than 0. The solution set of this inequality is also the same 1 2 interval, fine. So, this is if and only if I expand this, it is simply it is x square minus 3x plus 2 less than 0. So, this forces, now I can compare the coefficients, therefore, by this forces that b by a is equal to minus 3 and c is equal to 2a. C by a is equal to 2, therefore, c is equal to 2a, and note that a is negative. Now, I am considering, so this is the information we have got, b by a is minus 3 and c is equal to 2a. Now, let us look at the other in the inequality in question, cx square plus bx plus a. So, let me write the equation. Therefore, the cx square plus bx plus a less than 0 if and only if I am substituting the value for the c. So, 2ax square, I am writing everything in terms of the a. So, 2ax square plus minus 3ax plus a is less than 0. So, this in the solution set of this inequality same as the solution set of this inequality. Now, this is if and only if I am dividing by a, it becomes 2x square and a is negative, remember. So, 2x square minus 3x plus 1 is positive. The solution set of this inequality same as the solution set of this inequality. Now, I can factorize this inequality. This is ordinary quadratic inequality, therefore, I can factorize simple one, 2x minus 1, x minus 1 greater than 0. Now, using the sign graph we can see that both the terms have to be positive or both the terms have to be negative. So, that the product will be positive. So, therefore, now I can write down the solution set. Therefore, the solution set is from minus infinity to half union 1 to infinity. Okay. So, this is the solution to this problem. So, today we have seen the inequality. So, we have to be very careful with the inequalities. For example, mod x greater than a, x square greater than a. So, what it's immediately we should not commit a mistake. So, these are the very small things we have to be very careful when we deal with the inequalities, and in this today's lecture we must have learnt about how to solve the quadratic inequalities. Okay. So, if you are given a quadratic inequality, for what values of x the quadratic inequality is satisfied, and at the same time if the quadratic inequality is satisfied, what will be the parameter a. So, the converse problem also we have seen. So, both are very important. So, and I am sure we may have learnt about finding the solution in both the cases. Thank you very much.